A resistor of resistance R, capacitor of capacitance C, and inductor of inductance L are connected in parallel to AC power source of voltage epsilon naught sine omega t. The maximum current through the resistance is half of the maximum current through the power source. Then the value of R is to be determined. We have the potential difference across a resistor is equal to the value of the resistance multiplied by the current flowing through the resistor. Therefore, the current flowing through the resistor is just the potential difference across it divided by the value of the resistance. And hence we have IR is equal to epsilon naught sine omega t divided by R. Now let us try to find the AC current through a capacitor. We have the potential difference across a capacitor is equal to the charge stored on the capacitor divided by the value of the capacitance. So we have the charge stored is equal to the value of the capacitance multiplied by the potential difference across it. Therefore, charge is equal to epsilon naught into C into sine omega t. Therefore, by differentiating it, we get the current across a capacitor is equal to omega into capacitance into epsilon naught sine omega t. Again, we can take this logic to the inductor, where we have the potential difference across an inductor is equal to the value of the inductance multiplied by the rate of change of current flowing through the inductor. So we have dIL by dt is equal to the potential difference over the inductance, or dIL by dt is equal to epsilon naught sine omega t by L. Now we can just take the antiderivative on both sides and we get the current flowing through the inductor is equal to epsilon naught cos omega t divided by omega L, and we put a negative sign here because the antiderivative of sine is minus cos. This actually has another term of a constant current, but we can ignore that since we can't have any current when the loop is open and there's no potential difference which is input. So now we can calculate total current from all these values. So I total is equal to epsilon naught by R sine omega t plus omega epsilon naught C minus epsilon naught by omega L, the whole thing multiplied by cos omega t. Now suppose we take the square root of epsilon naught by R whole square plus epsilon naught C omega minus epsilon naught by L omega whole square to be equal to some value capital K. Then we have I total is equal to capital K multiplied by epsilon naught by R divided by K can be considered to be the cosine of some angle, and this bracketed term divided by K can be assumed to be the sine of the same angle. So we have I total is equal to K times cos theta, let's say, into sin omega t plus sin theta into cos omega t. We can be sure that this term by k and this bracketed term by k are sine and cos of the same angle, because the sum of their squares would clearly be equal to 1. So now what is I total max? This is clearly equal to k, since the term inside the bracket is sine of omega t plus theta, which can have a maximum value of 1. The maximum value of I total is k, and the maximum value of the current through the resistor is equal to epsilon naught by R. And we are given that the maximum current through the resistance, which is epsilon naught by R, is equal to half of the maximum current through the power source, that is 1 by 2 k. So we can rewrite this part as 2 epsilon naught by R is equal to k, and I'll just write the full expansion of k here. Epsilon naught by R whole square plus epsilon naught c omega minus epsilon naught by L omega whole square. Now we can see here that these epsilon naughts are just a constant multiplier and they can be cancelled. And when we square both sides, we get 4 by R square is equal to 1 by R square plus C omega minus 1 by L omega whole square, or 3 by R square is equal to C omega minus 1 by L omega whole square. Transposing these terms, we can clearly see that 3 by the absolute value of C omega minus 1 by L omega is equal to R, and we have the square root of 3 here because we are taking square root on both sides. Therefore, option A is the one that matches with our solution.